Good morning, everybody. While you're sitting there in a chair, I'm probably out hiking in the Alaska wilderness or fishing or something. So enjoy yourselves today. We're going to talk about Olympic winning times and how we can model those winning times to predict future Olympic winning times. It's just a way to use data to predict the future and analyze the past so that we may not replicate it in the future if we don't want to. You should have this sheet on your Google Classroom. I'm not giving you printouts again. Just saves time and paper. Your data analysis will involve the 100-meter dash, which of course we can say that Usain Bolt was king. 2016, he only ran a 9.81, but hey, it was fast enough. Got the gold medal. Did his triple in the 100, 200, and 4x1. So that's pretty cool. I'm going to show you what you're up against here with a different set of data. And I'm actually going to use a swimming example for those of you that are bigger fans of swimming. These are the men's 100-meter freestyle times. So that would be down and back in an Olympic pool, and they can go as fast as they want, as fast as they can with whatever stroke they choose. This is the data I pulled. It even has Rio on there already. The first thing you're going to be asked to do is just to do a scatter plot of that data. Notice the year and the time. Those are the two things we're going to look at. On my scatter plot, and I trust you guys have done this before, the time is always the horizontal axis. Okay, that is just because it's a steady reference, and it can show us a good trend over time. In our case, the horizontal axis is time in seconds. Okay. Always put your units. Notice that on the x-axis, I've put years since 1908 because that's where our data started. First was 1908. This was all kind of not worth using. So that would be year 0. Year 4 would be 1912. Notice there's no year 8. Year 12 would be 1920, etc. Okay, so be aware of that. It will be a lot easier. You'll get much better equations if you use the years since model instead of just the years. Okay, so you've plotted your data. It's got labels. You're going to have a title. Make sure it's nice and clean. If you need to break it, put one of these squiggle lines. You don't have to put this on it if you don't. No, you shouldn't. It's not convention. I just did that to point it out. So if you want to break it, you can. And the other thing that this years since model gives us is that you don't have to break the axis on the horizontal axis. Okay, so you're going to scatter plot, and then you're going to be asked to create a linear model. Now you can see I already have the equation here. Well, how did I get it? On your calculator, you need to, hopefully you've seen this before, so it's a review. So you turn it on, obviously. There's a stat button. That's where we do our statistical analysis. Okay, so we're going to hit stat, and this is edit. So hit enter. And you can see that I have already put the times in here, or the years since, so 0, 4, etc. in list 1, and the times in seconds, because that's what my axis is, in list 2. Okay, and of course I went all the way through. It's not that much time. It only take you a few minutes. You just get her done. Okay, so list 1 and list 2. Quit out of that screen. Go to stat, calculate, and go down to number 4, linreg. Of course, we put our data in list 1 and list 2. If you need to change that, you can change it here. It's already on. You just have to push L1, L2, L3, these buttons here. Okay, and just go down to calculate. It should all be set up for you. And it gives you your equation. So the A value Negative 0.177 is your slope, because that's what it tells you. It's a times x. The b value is your y-intercept, 62.12. And let's talk about the r value, negative 0.9677. Okay, so there's your calculator exercise. You can plot this as a scatter plot in the calculator. If you're on a Google Chromebook, you should be able to take a screenshot. Well, I guess you can't take a screenshot of your calculator. You could take a picture of the screen of your calculator. So if you go to stat plot, so it's second y equals, plot 1, turn it on. Type, you can do a dot. That's just what it does. List 1 and list 2 again. And then set your window. Let's see, our x is time from 0 to, let's call it 112. And the scale we can do every 4 years. The y goes from, let's start it at 40, because that's where I did, up to 80. And we're going to go by 2s, because that's what I did. And graph it, and there's your data. So you can take a screenshot of that, but be aware there are no labels here. You're going to lose a lot of points. Okay, so that's kind of a quick and dirty on the calculator, doing linear regression. Note that you're going to need to draw that linear regression line. Okay. So at year 100, I'm going to take 17.7 seconds off of this and make it 44.42. Is that right? Let's check. We have negative 0.177 times 100 plus 62.12. Yep, 44.4. And then my starting value, 62. Then I'm going to use a ruler so I'm precise. There's my regression line. Okay. Notice it starts to trail off and become a little more difficult to match that data down here. Imagine this line continuing. Will we ever get to 0 seconds? Probably not. Okay, so hello. I'm on video. So there's your regression equation, your regression line. You can predict data. So if we were to go to the 72nd year, which is 1980, of course, it looks like it predicted it pretty well, just under 50 seconds, 49.5 or so. Okay, so sometimes it will do very well at predicting, sometimes it won't. It's a linear model. Okay, let's talk about the R value here. Hey, notice it is negative, right? That means negative slope. Remember our slope, negative 0.177. Okay. So that is all that. If it's positive, positive slope. Okay. So down to the right. This number can go from 0 to 1. Okay. Notice it can be negative 1 as well. Close to 1 means it's a very strong linear relationship. Okay, it follows the line. Right? 0, this is your shotgun blast. So the data would literally show no cause, no correlation whatsoever. It's just all over the place. Okay. All right, let's talk meaning. So what is the meaning of the slope in context? This is key because this is where you're actually, if you're like a psychologist or a scientist, this is what matters. Okay. Our slope was negative 0.177. Okay. Remember, slope is the y over the x, right? So our y is time, so seconds over, or sorry, whoa, I goofed that up. That's not, yes, time in seconds, sorry, divided by time, years since, okay, 1908. So what this means is we are dropping 0.177 seconds per year in the Olympic men's swim of 100 meters freestyle. Okay, I could have structured that sentence a little better. Okay, notice a couple things. It's only per seconds per year. This is a rate, so it's going to be days per month or meters per second. All right, this is always singular. Notice I did not bring the negative here because I was said dropping. Okay, if I would have said dropping negative, that means it's actually going up. So I had to use my language properly. Okay, you could have said changing negative. That would have meant the same thing that I wrote here. So be careful with your negatives, okay? The y-intercept was 62.12 seconds. So this was the time at year 0, right? Here's year 0, the y-intercept 60 on the linear regression model 62.12. What does that mean? This was the 100-meter freestyle men's swim time of 62.12 seconds in 1908. Make sure you write sentences. Okay? Sentences. I will be scoring you on writing sentences. I'm just checking to make sure I've covered everything. Yep, I think we're good. So if you have any questions, you guys do have your Chromebooks, turn this video back on. Look through that calculator procedure. You can play it again and again and again if you want. So use your resources. Again, if you're really confused, we can talk about it when I get back, but use your classmates as a resource. These videos, there's probably a couple of old videos of this on my YouTube channel if you want to look at those. Khan Academy probably does it. There's probably videos everywhere. So do what you have to do to learn it. Hopefully this was enough for you. Toodles.